Cool. Okay, we'll jump straight into it. So yes, as Matt said, we're from Manna, and we're going to go through some of the challenges and a bit of our journey over the last few years of how we do drone delivery.
Yep.
Cool. So a quick intro to ourselves. So I'm Dan. My background is in robotics, mainly on the software side. I've been with Manna now for just over 6.5 years. And in that time, similar to Charlie, I've worn many hats, from flying to building, whereas now I'm kind of sitting on the safety systems and integration.
And then, my name's Charlie. I'm currently Manna's aircraft team lead. My background is in physics, so a bit of a different story. I also joined Manna doing software and have worn also many hats along the way, been at Manna for about 6 years. But it's been an exciting journey along the way.
Cool. So what we're going to go through, some of like how Manna works in general, in case anyone hasn't heard about us, go through some of the challenges, and have some extra questions at the end. Do feel free to have questions throughout. If there's anything specific, just put your hand up and we'll get the mic around. So yeah, Manna, we have been operating for basically the same time that we've been in the company, so 6 years. We're a last mile delivery service, so we're solving that short problem of getting the delivery to your door. The aircraft, we carry up to 4 kilograms, and that's typically within 3 minutes. That means we can keep your hot food hot and your cold food cold. So whether it's a coffee or an ice cream, it'll arrive in good nick. Time is money, so hopefully when we get the PPP and the Ethernet, we can get quick turnaround times on the landing pads, and make that even quicker. We're in 3 main locations, so not just here in Europe, we're in the US, so we're based in Texas, and then our main headquarters is in Dublin, and we also have an operation in Helsinki. Overall, Manna employs about 150 people, including operations, and we're trying to solve the broken problem of road delivery.
Cool. So I'm going to talk a little bit about how it works. So it starts with somebody putting an order in via an app. That can either be our app, so Manna has its own delivery app, or via one of the kind of like food aggregators you've got, people like Just Eat, Deliveroo, and DoorDash. That order is then prepared by one of the vendors. So that would be one of the 50 local businesses that we work out, for example, in Blanche. That order is prepared, put into an aircraft. Our system then goes and generates a flight path for it that goes and that takes us to the customer's house. And then the aircraft goes and flies that and then delivers to somebody's back garden. So we deliver from about 14 meters. And you can see here an example of an aircraft doing a delivery. It delivers the package down on a bit of string. So winches down, and then we leave that in somebody's garden, and they go have their takeaway or whatever it is that they're ordering. We operate 7 days a week, and it's a service offered to thousands of people, and we do it in 97% of Irish weather.
Importantly, it's the Irish weather. Like, it's very windy, it's very rainy. I don't know why we chose this location, but it's a great test bed, so we can deliver basically anywhere and a lot of the time. This is happening right now, so we get a question a lot of the time to be like, where are you operating? How often you're operating? 7 days a week in those locations. This kind of covers how we got there. So this is, again, just a load of pictures to take in, and we're just going to go through how we kind of go through this crawl, walk, run approach. At the beginning you can see literally testing on small test beds. That's just a small 450 Discovery. And we literally went from learning quickly in the field, dirty bean bags, farmyards, whatever it was. We were a small team, iterating quickly and getting those rapid prototypes, learning all the mistakes as quickly as we could. The main problem we were trying to solve at this point was working out what drone delivery looked like. So there was no playbook, there was no answer. It was just what do we do to solve this problem?
And then from there, we had our first prototype. You can see it there sitting there in the barn. And with the next stage was like trying to take that and actually going and do operations for the first time. So we started in a place called Manna, and we kind of scaled from there. And there we were doing only a few orders a day, but it was kind of like our proving grounds. But to get there, you need to do a lot of testing. And so you can see here some examples from the testing that we've done. You need to make sure that your testing outpaces your and environmental testing is key. So you'll see some pictures there from the snowy winters in Finland, all the way to the heat in Texas. It's very key to as we say, make sure your testing is outpacing what you're kind of doing in your ops environment.
Yeah, so it was really important to close that loop between the testing, feeding it back into our operations. So we're now at the point where we've done a lot of that learning. We're still obviously learning, but we can now scale what we have. So on the third row, you can see we do a lot of automated testing. So the issue is if you bring an issue into this kind of scaling phase, it means it takes longer to close that loop. So it means you have to redesign something. You then have to go through this cold testing, hot testing, and do all that again. So the earlier you can find something, the quicker you eventually get. So we've built this confidence. We're now able to see, like you can see all the drones kind of lined up there, ready, like they just got their maintenance done there, I think. So we can build that confidence, we expand, we get that consistency. So if anyone has any kind of manufacturing line, or maintenance or checks or dealing with people, trying to get the same repetitive tasks over and over again is really tough. So we try and solve this with automation, and that's really key. We have robust checks for commissioning, quality control, any of the kind of pre-arm checks. Like we've taken a lot from the RD Pilot community and learning just to see what works and what we can do quickly and what takes a bit more time.
And it's worth noting that like simplicity is really key here. Like you shouldn't add anything to your process that you don't need to, but it needs to it needs to be robust, but also keep it simple. Don't make it too complicated.
So like you can kind of see in the middle picture on the right, like everything's kind of spaced out there, like it's a good few meters between the pads. You can be very conservative, whereas we've gained confidence. We can now fly much closer together and have the aircraft just being up and down very quickly. So safety is still like really key, obviously, and it's at the heart of everything we do. So as we grow and continue to scale, it's really important that we maintain the same safety level. So even if we're going from 100 flights to 1,000 flights to 10,000 flights, you need to maintain the same safety level through it, like, and keep improving it. So this is the Dublin suburb of Dublin 15, which we call Blanchardstown. This has 3 bases. You can kind of make them out as the dots between the drones.
Quite a lot. The GIF goes quite quickly, so it was what could fit in the PowerPoint at the time.
So this is 8 kilometers roughly in this whole space with the 3 bases inside there.
It's just to give you an idea of what a day's worth of deliveries looks like. So you can see all the little dots flashing across the screen very quickly. There's all the little logos of the different orders that have been made. On this screen, the red dots there, they basically represent all the different deliveries that have been done previously. The size of the dot is kind of the number of orders that people have made. And then all the green dots, they're all the deliveries that were done that day. So you can see the scale of just even one of our cells. It's a lot of flights that we're doing every day in, day out, 7 days a week.
It's a lot of flying. I think that's probably one of the key things we're trying to show off here is like, it's a lot of flying. This is RD Pilot code flying a lot in the real world.
So next on is talking a bit about how we do reliability. So I'm going to just intro a little bit the framework that we use, just to give people a bit of context. So we fly under the European regulations, and we fly under something specifically called SORA, and that has different levels to it, and they're associated with ground risk and air risk. So in a very, 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 very simplified way, I've tried to relate these down to something because there's a whole process that you go through to go and work this out. But I just wanted to give people who haven't been familiar with the framework a bit of a feel for what that it kind of like relates to. So you can kind of approximate Sail 1 and Sail 2 to being kind of like operations over the sea. Not many people at the ground, like on the ground. Maybe the ship or two or something like that. But Sail 3, that's what we currently operate at. That is that kind of represents kind of suburbia. And then like Sail 4 Plus, that's really like dense urban environments, so like city centres and things like that.
So yeah, we fly at Sail 3. We have a LUC, which is a certificate that allows us. It's just a proven certificate that lets us allow to fly in these places. We also have cross-border, so we can open up new bases using our own risk assessment, which is very useful for Europe as we scale. We have a similar thing in the US as well under the FAA. Again, that's another challenge we'll come to later. Is kind of balancing Europe, America, and other places as we go around. So yeah, finding the common ground between the different solutions. We use functional-based testing. So as you can see, we have the parachute testing going on there. So that's following ASTM, 40 plus parachute things. When anyone ever asks who has crashed the most drones in Manna, this guy. Yeah, how many parachute testing is key, and repetitiveness is there.
But yeah, we've done a lot of flying hours in that time. To demonstrate it, you have to demonstrate that kind of level of reliability. You have to do a lot of flying, and right now we're sitting at over 15,000 flight hours.
Yeah, that's in all the conditions. Like that covers all the conditions because we're flying so much. That covers cold, wind, rain, wet, dark, light. We're trying to figure out
entire flight envelope. From low wind conditions, high wind conditions, gusting, you name it, icing conditions, whatever it might be. You have to have tested in all those conditions to know the limits on your aircraft.
Another challenge we had here is defining what those are. So a lot of these are defined for manned aviation. That doesn't always equate to our kind of smaller UAS sized aircraft. So trying to get that overlap between what was manned and what is like the drone space, we have to make up a lot of our own definitions based on the evidence that we're kind of given.
Cool. I'm going to talk a little bit now about how we actually go and demonstrate that. So this may be things people have seen before or not. It's something called CPM. It's basically a method for people can think about it kind of like a hypothesis. People familiar with kind of hypothesis tests? People remember that kind of stuff from school? It's effectively a hypothesis test, and it's telling you about as you fly, you can gain a confidence on like an underlying failure rate. So, for example, for this, I think this graph is for Sail 3, isn't it? So, for Sail 3, you need to have completed about 3,000 flying hours to reach 95% confidence in your aircraft's ability to fly, and that's with no failures.
That's the blue line.
So that's the blue line here. And then Dan's going to talk a little bit about what that does as you're growing and learning on the way, because it's not going to go perfect first time.
Yeah, so I wouldn't be doing my day job if we weren't trying to stay safe. So the easiest kind of way to represent this, so each kind of black dot is what you'd class as a failure, a top level failure. As soon as you kind of get to the, I can't remember this like, so as soon as you kind of get to the higher, like 80, 90 kind of % range, if you get a failure, it will drop a lot less. So every time you get a failure, it drops straight down. So if you get to 40%, you lose a lot of confidence. And I think you get that in a personal way as well. So if you're flying something that you just built, you'd be flying it around, oh, it flips over straight away. Oh no, my confidence is kind of shattered and I have to try and build up that confidence again. It's the same for this. So yeah, you lose a lot of confidence, but you kind of have that bathtub curve. You gain your confidence back, you build up your hours. As you get it back to the top and you keep gaining those hours and then you learn something new, it'll drop, but not so much. And again, if you have you keep those hours, you drop again, but you still maintain it. If you kept getting failures, it would drop down very quickly. So we're obviously trying to maintain a consistent number of hours to number of failures. And that kind of goes back to as we're flying more and scaling, this becomes more prolific because if you aggregated that all the way to like 20,000, 100,000 flights, you're going to get failures of some kind, but you need to make sure that
Yeah.
still outpacing that growth.
Yeah. So, as kind of going back to what we mean by top level failures, that's if anybody's done a fault tree for their aircraft, maybe people might have, people might not have done. They're the things that sit at the very, very top. And often those things don't happen from one failure. So our aircraft is single failure tolerant. So that means you can rip out any one part of the aircraft and the aircraft survives. But if you happen to have a failure where two things line up at the same time, that's one of those events for us. And it'll be different for different people. But yeah, it's a really effective way of tracking like your progress and your internal confidence. And it's a great way to demonstrate that to the regulator. So, they're going to come to you and they're going to say, well, how do you know your aircraft is safe? And this is like the framework to be able to go and prove that to them.
And it's not linear, as you can see. So it's as you gain more hours and keep pushing that through, you plug it into the algorithm and you get your number. And then, yeah, we mentioned failures. So like we can definitely show some of these learnings. So we tried to put this into two buckets. We had a bit of a discussion on trying to make this in a way that was like super usable. So like people get it wrong. People are tough and the sensors can get it wrong. And anytime that you can make a binary decision and just shorten down how many choices you have, it's a lot easier to do a root cause analysis.
Yeah. So I'm sure people are kind of familiar with the common failure modes, and we've kind of gone through them all. Compasses, rangefinders, GPS on occasion. They're all great learnings that we've had in the past. I'm glad we've kind of moved away from compasses now, and they're not our primary sensor. They were a right pain.
We're using GPS baseline for yaw.
Yeah, no, we use GPS baseline for yaw. But yeah, like I mean, people are very familiar with this kind of stuff, and you've got to try and like we've solved the problem of redundancy. But when I've been talking to a lot of people around the conference actually about that, and like people said, some people maybe not convinced by redundancy. Some people think it's like some people have started kind of venturing into that space. But yeah, you kind of need to solve the sensors problem first of all. Start with sensors, make sure that's robust, and then you can kind of then think about then taking that into architectural redundancy.
Yeah, and then on the other hand, people make mistakes. There's always a thing of if you have a square hole, if you have a round hole, someone will get a square peg and try and push it in. It's very common. We see it on the drones all the time. We'll get to it a bit later in the automation on how we solve this, but like people, if they have a button, they will press it. So if you give them a transmitter, there's many buttons on the transmitter, so they'll try and press them all. So one thing we kind of did was start phasing out in the operations. And that was mainly from a couple of cases where we had the e-stop and mode switches accidentally being hit.
Dan, about that one, don't you, Dan?
Yeah, so we ended up having 2 e-stops pretty quickly because when I was giving a demo to the CEO, to Bobby, we were showing off our software and we were like, this is great. Turn around, knock the switch, aircraft dropped out the sky for the testing, and then that was that demo done.
So you still need to use this kind of stuff when you're kind of like in your development phase. But for us, it became the fact that like RC became one of our biggest failure modes, and we had to phase that out. So specifically for operations, I see there's a question.
Yeah, have you got any data around that? One of the interesting things I'm facing in Canada is the regulator seems to have the attitude that we don't trust the technology. So you have to have a human in the loop to make sure that when the technology fails, the person will be there to save it. And we always seem to be telling an opposite story. But have you got data that says, oh yeah, X number of failures were due to people versus the technology and that kind of thing?
Absolutely, yeah. So, and that's kind of what drove the decision making is that we monitor. One of the things we do is we collect a lot of data, and we make really use of that data as well. And so, what happened was effectively like our most common failure mode was the pilot at that point. And it's probably not the case for everybody. If you're doing lots of development work in Ardu Pilot, you're making frequent software updates, major software updates, testing new features, you might sit at a different risk balance. Then you're testing very, very different code or whatever. But for us, we've used I kind of say to people here that we use a kind of a narrow set and kind of a well-trodden path within Nadu Pilot. And we've built up a lot of confidence over that time to put, of use of that kind of like that base set.
We still do have a human in the loop. So we haven't like completely removed the human. We do need it for that sense. They just don't have a transmitter. They have 4 buttons that they can use.
So it's a much more simplified interface for the pilot. And it was just like, it was examples like that. You've got to imagine, particularly like at our test site, because we're doing such a volume of flight testing, there'll be a person sitting there, rinse and repeat, 10 flights an hour, something like that on a single aircraft. And then maybe they're operating several aircraft at one time. And you can imagine it's quite repetitive. And it's like those kind of mistakes. Somebody the classic example that we had was, somebody lost track of their aircraft and, hit the buttons accidentally in the test site. And then, the aircraft comes under the parachute. But it's not what you want to be doing. So data drove that decision.
And it's the same thing with parameters and configuration control. Everyone always loves how many parameters we have, and then also how we control those. So for me as well, like, we had a few different flavors of aircraft. So like for the example in this one, we had some aircraft with the flight controller facing one way, one the other way. AHRS configuration, AHRS orientation is very critical, and making sure that things linked up and you had the automation to make sure all of those checks were in place.
And that's another good point, is like have process when you're doing your development testing as well. Have your common checklist, like you might be like we manage configuration automatically these days. But for dev testing, you still have to, there's somebody going and changing these things. But having your tick list, make sure you've got your critical steps down, so, you've done your horizon check or something like that, make sure that, that's a very simple example, but like it's kind of making sure you've got those basic steps to make sure you're flying safe.
And like these were kind of earlier examples. So like, we keep learning, we keep adding. Like the main thing is to find out the issue, do the root cause, learn from the mistake, don't do it again. So
you've got to make sure you're always learning and improving. If you do the root cause and you don't learn from it, it's no use. And if you don't do the root cause, you really should start doing it.
And Beckett had a great quote for this. So it was like, try again, fail better. So we try and put that into everything that we do.
So a little bit about automation. I'm not going to go into too much detail, so we have a bit of time for questions as well. But there's lots of stuff that we do with automation when it comes from pre-flight checks. One of the requirements is obviously that we have no single point of failure, but that means that you also can't take off with latent failures. So we have to have lots of automated checks on board the aircraft to make sure all the systems are go before flight. There's lots of stuff that goes on inside of our flight routing system. So we actually route aircraft in 4D, and it sounds very fancy, but what that basically means is that we know where the aircraft is at any moment in time, so we can route missions around each other. And that's kind of like, if you think to the UTM space, which I'm not going to touch on, but it's kind of like, it's like heading in that direction, but we needed the solution for ourselves before we got into that. And then also things like being adaptive for weather conditions. So copters don't fly airspeed, but we have an aerodynamic body shell, and we kind of want our aircraft to be flying in the cruise phase. At least we want to be able to fly it almost more like a plane than a copter. So we had to build a whole system around that. And the key is you've got to do that in an automated way.
And then one way we've been able to so the whole kind of scale and scope of drone delivery has kept changing over time. So how do we manage to stay developing really quickly, but also under control, but also being able to adapt as we learn? So we are able to put humans in the loop in a strategic way. So for example, like loading packages, we still don't really know exactly what a loading a package is going to look like, whether it's the vendor, whether it's us, whether it's the drone, whether it's an arm, whatever it is. We don't exactly know what that looks like. We've tried a few different ways. It's still changing. Same for ground condition monitoring, same for airspace monitoring, and any of these kind of unknown unknowns. So when there's a vendor who's delayed because, I don't know, someone forgot your source, so then they have to run over with the source and be like, oh, here's a source for your chips. How do we make sure that the aircraft still takes off on time, or we have to swap with another aircraft? So it's air traffic control management at that point.
And like the problem we're solving now is that you're having to imagine a solution that's flying thousands of flights a day. So without automation, you can't do that volume of orders. So everything that we think about day to day is in that kind of like frame of mind. It's like, how do I do this in an automated way? How do I make it safe?
Cool. So yeah, we're just trying to minimize the human interaction. And then kind of the one way we try to summarize this is within like 4 pillars. So we have automation, which really enhances safety and that vendor interaction. We then have safety. Customers wouldn't order from us if we weren't safe. And then the vendor has to provide that service to the customer.
Even just the number of vendors make a big difference to like consumer demand, for example. So
we found like vendor selection and the variety for the customer was one of the biggest drivers. So all of these kind of come together and give us viable suburb delivery. And as we've kind of gone through these hundreds of thousands of flights, we've flown to the moon, which is a very cool kind of fact. Like ArduPilot has flown to the moon, and you could say we've flown there and back and there again, because we have 3 redundanciness. So I'm sure Philip will love to claim that his cube's flown to the moon. And then if we go on to the next slide,
just some shout outs to people who've kind of helped us along the way, and like the people who've as well. So thank you very much to ArduPilot. It's been the launch pad for us, and it's been the launch pad, I think, for a lot of people here in this room and beyond. And thank you to KH and 3DXR as well for putting on the conference.
Yeah, we've interacted with quite a lot of you, whether it's on a technical or like a day-to-day kind of basis. We just wouldn't be able to do what we would have done without it. It's super key, and we're super open. Like, we try and stay open, and we try and give back where we can, even though we are, like we said, in that very narrow thin...
in our little vertical.
But yeah,
cool.
If anyone has any other questions, that's the end of the slides.
Hi there, really interesting talk and really awesome work that you guys are doing. One of the biggest concerns that I've heard about drone delivery is noise pollution. Have you guys realized that? Have people been complaining, or?
Yeah, we definitely work on that. It's one of the things that we do. We spent a good bit of time working with manufacturers on different propellers. So it's a key part of the design process. It's definitely something that we're conscious of. We've actively worked on a solution with slightly larger props that makes about a 3 decibel reduction in noise. So we're definitely conscious of it, definitely working on it. I think it's going to be a constant evolution over years. I mean, it's a problem I think a lot of people have to deal with. The obvious thing is larger propellers, because you reduce tip velocity. Like, people know the science in here in this room. But yeah, it's a real problem, and you have to think about it. We do lots of clever stuff in routing as well. So we make sure that we try and disperse traffic over different areas of like kind of the operating area. And then we also run asymmetric routes. So you kind of like fly over one side of town to get there and another side of town to the... It's the kind of stuff to try and be respectful. I think that's what we're trying to do. We're trying to be really respectful and engage the community on it.
Okay, really interesting. Thank you.
Great talk, thank you. Interested in your reliability approach. How do you treat that with respect to design updates on the aircraft and also software updates? Do you reset the clock, or do you kind of take that as being a continuation?
Yeah, so it really depends on the type of update. So like, if we're doing something development like really like prototype kind of testing, we have that in kind of one bucket. And then if we're doing production flights, then that will push towards our overall claim as such. So like we have the same configuration control to lock down. We have the same traceability. Like, it's the same process. It's just how you count it.
So we work with the regulator on a process for that. And part of the benefits of what we talked about in terms of CPM is it's continuous probability monitoring. You know, so you can be making those design updates as you're going along. The updates you have to agree that with the regulator about how you phase those in. You have a lot of freedom in your developing and testing environment. But then to get that into production, there's a process. You need to agree that with the regulator about how that process works. But then the beauty of this is it's kind of like it's measuring you as you go along. So you could start this on day one. Like there are certain cases maybe where you have like a complete revolution, you know, an architectural shift, in which case you maybe would want to set the clock back to 0 because you're not working with the same thing. But we measure ourselves in 2 ways. We measure ourselves both on like a specific generation of aircraft, but also just Manna as a whole, right? So like from day one, you know, how are we doing? What confidence do we have in ourselves? And that kind of is a bit of measure of also like your design process. How do you take that from test and then get that to operations? So it can be a bit of both,
Great, thank you.
Throw up the other test.
Oh yeah, I'll see if there's some bits and pieces going on. See if I can throw that up.
This may be more of a bar story, but I'd love sort of those failures that kicked you down the reliability chart. Like what happened and what did you learn?
Sorry, can you say that one again?
So those failures that kicked you down the reliability curve, your one failure at
Yeah.
3,900 hours. Any interesting stories to share, or is that more of a later discussion?
That's probably more of a later discussion, but like we definitely had a few, like we were saying with the manual sticks and manual control. But like the one thing we can say is like every time that we've had one of those high level failures, the platform has performed as expected. Like EASA, like they publish their safety report, and like UAVs and UASs are still like way lower overall than like manned aviation.
I just thought I'd throw this up as well. This is currently a live view of our Blanchardstown operation. So you can see there's 3 or 4 or 5 people getting their lunch delivered to them at the moment on a Saturday. But yeah, just so people know, you can see it in real time. This is going on right now in Dublin.
Yeah, it'll switch between some of the heat map of like what we were saying with the routing, and then just the aircraft telemetry and stuff.
Switching views.
So thank you, very impressive work. My question is, do you ever need and do you have onboard collision avoidance between the drones, or all the path planning is central in your...
Yeah, we do a lot of strategic deconfliction. Like the drones each know where each of them are. And we're still like, there's lots of work going on how we like communicate with other providers and within ourselves.
Great talk. I suspect you're familiar with Part 108 and the US proposed regulation. Can you talk a little bit about it and what's your opinion and assessment of it?
Yeah, so like I think that's another kind of conversation on the population density side of things. So whether like EASA are going to become like the provider or the facilitator. We're currently on some things on SORA 2.0, and there's a lot going towards SORA 2.5. So again, there's a bit of adjustment for that as well. So I think we'll have to wait and see for some of it.
It's quite new as well, so like it's kind of like in a review process at the moment, and probably me and Dan aren't the best people to talk to it. We sit more on the engineering side, and I'm sure there's probably someone in Manna who's better qualified to give a really detailed answer on 108. But yeah, so it's kind of like in the consultancy process. I know Manna's looking at it, but I don't know if we'll have loads and loads of detail on that.
Fantastic. Thank you very much, both. That was a fantastic talk. One more round of applause, please.
Thank you for joining us for the RDU Pilot Developers Conference 2025. With thanks to our sponsors, 3DXR, Aerosystems West, CUAV, QPilot, High-Tech, Holybro, IR Lock, KH Unmanned, Kraus Hamdani Aerospace, Maytech, Modal AI, Northwest Blue, SD Model, and Theseus. Organised by KH Unmanned. Hosted by 3DXR in North Yorkshire. Broadcast by Q Branch.